Okay, so today we're talking about area of composite figures. Now, it says at the top of this area of composite figures, day 1. I had a student teacher last year and she did it in 2 days, but I'm doing the lesson in 1 day and then you guys have 2 days to do it. So that's nice, right? Okay, and it's not day 56, it's day 5/6. The slash didn't show up when you converted it. Okay, so what is a composite figure? A composite figure is made up of simple shapes that we've already known, such as triangles, rectangles, trapezoids, and circles. To find the area of a composite figure, find the area of the simple shapes, and then either add or subtract them depending on the situation given. So let's look at our first problem right here. It says, find the area of this shaded region in the diagram. If necessary, round to the nearest tenth. Okay, so if you get a nice answer, no need to round. If there's pi in your answer, or if you get a decimal that goes on forever, we are going to round that to the nearest tenth. Okay, so here's our first composite figure. So first thing we have to do is make a plan. We only want the shaded region. So what's our plan? So what shapes do we see? I see a rectangle and I see 2 circles. Those 2 circles are exactly the same. So if I want to find the area of just that blue region, I'm going to have to find the area of the rectangle and then get rid of the 2 circles. So first thing I'm going to do is I'm going to write down my plan. My plan is to find the area of the rectangle and then subtract the 2 circles that are exactly the same. Okay, so let's start with the area of the rectangle. Area of a rectangle is equal to base times height. So base is 30 times height, which is 20. So now I can get my area of my rectangle, 30 times 20, 600 inches squared. So one thing that I can tell you about my answer right now, my final answer, it's less than 600, right? All right, so now I'm going to find area of one of the circles. So area of one of the circles, which is area is equal to pi r squared. So I'll put the pi there. And then I need the radius squared. So if you look at this circle, did I give you the radius? Okay, my notability froze, so I have to exit out of it really quickly and then open it back up. This happens sometimes. Okay, so in this circle here, did I give you the radius? No, but I gave you the diameter, so I can get the radius. It's just half of that, so my radius is 5 inches. I'm going to put the 5 in there. So that is 25 pi inches squared. Notice I'm not changing it to a decimal yet. I wait to change it till my final answer. All right, so now I'm going to go back to my plan. My plan was to take the area is going to be the rectangle, which is 600 minus 2 times the area of the circle. And now I'll pick up my calculator and put that in my calculator. I'm going to put the whole thing, including the pi, in the calculator. I'm typing 600 minus 2, parentheses, 25 pi, close the parentheses, and then hit enter. If you didn't get your calculator out, pause the video, go get it, try putting it in, and see if you can get the same answer as me. You should get the area is 442.9 inches squared. Right? Not bad. This stuff is usually, since doing the first few sections, people are like, oh yeah, this is not so bad. All right, next one. So first off, I have to look at it and say, what do I see? So I see this shape. That's half of a circle, which is called a semicircle. And then I see this shape, which is a trapezoid. So notice it's a combination of those two. It's like a semicircle roof with a trapezoid bottom of your house, right? So I'm not going to subtract these two. My plan is to add them to get the area of the whole figure. So I'm going to do semicircle plus trapezoid. Okay, so let's start with the semicircle. Area of a semicircle. All right, you might be saying, you didn't give us a formula for area of a semicircle. It's just half of a circle. So it's half of pi r squared. So I need my radius. Once again, I didn't give you your radius, I gave you your diameter, but you can see that your radius is 10 millimeters. Okay, so now I'm going to keep this answer exact for now, right? So what's 10 squared? 100. What's half of 100? 50. So the area of that semicircle is 50 pi millimeters squared. So notice I'm not using my calculator usually until the very last step, or if I need help with like the mini mental math. I know that I just said mental math, but you know, like if I don't know what, or if I want to double check to see what 37 plus 46 is, I could use my calculator to do that, but I'm not doing it. I'm not doing it for like what's 50 pi. I'm just going to leave that for now until I get my final answer. All right, next, area of the trapezoid. All right, remember area of a trapezoid, I'm going to write it off to the side right here just to make sure everyone remembers it. It's 1/2 base 1 plus base 2 added up times the height. Okay, so I'm going to do 1/2. I'm going to add the 2 parallel bases. So I'm going to look at my parallel bases. Here's one of my bases. Here's my other base. So 20 plus 32. And then times the height. The height you can see is 14. Okay, so you can either do mental math of this or you can use your calculator. All right, if you're using your calculator, I would use 0.5 for the 1/2, parentheses, 20 plus 32, close it, times 14. So if you do that correctly, you should have 364 millimeters squared. All right, now it's time to execute my plan. I said I was going to add those two things. So I'm doing 50 pi plus 364. Okay, so once again, in your calculator, you're typing 50 pi plus 364. Okay, if this was 50 pi plus 364 pi, then I would add those two first. I would say, okay, what's 50 plus 364? But this doesn't have a pi on it, so I'm just going to pop it all into my calculator. All right, and you should get that the area is 521.1 millimeters squared. Okay, next example. I need to find the area of the shaded region, right? So the shaded region is just that gray area. So I say, what do I see? I see a circle, and I see 1, 2, 3, 4, 5, 6, a hexagon. So what's bigger, the circle or the hexagon? The circle, right? So I'm going to find the area of the circle first, and then I'm going to find the area of the hexagon. And if I just want the shaded region, am I going to add them or subtract them? Subtract them. So I have the area of the circle minus the hexagon is my plan. Okay, so let's start with the area of the circle. Once again, I'm going to keep my answer exact until I need to put it into my calculator. Okay, so area of the circle. Area of the circle. Oops, I forgot my little circle symbol. Not mandatory, but I like to keep track of what I'm finding the area of. Pi times the radius squared. So I look and I say, was I given the radius of the circle? Sure was, it's 8. Or sure did, it's 8. That's 64 pi inches squared. Area of the circle is done. That was nice and quick. All right, now I need the area of the hexagon. Okay, now this is a regular hexagon with 6 congruent sides. Remember, the formula for area of a regular polygon is 1/2 the apothem times the perimeter. So I'm going to go through this a little bit slower because it's obviously super multi-stepped. All right, so you have 1/2 times, did I give you the apothem? So the question is this the apothem right here? No, we just said it's a radius, right? So I did not give you the apothem. I went to this switch. Once again, my notability is being a jerk. So let me open it back up here. Okay, where'd it go? There you are. Okay. All right, so this is not the apothem. So remember, whenever you are missing something in a regular polygon, you're going to want to leave a big space for it because it's not going to be the answer of usually like 6. It's going to be something pretty horrific looking, unfortunately. All right, did I give you the perimeter? Do you know each of your sides? No. So that's also something you don't know, so I'm going to leave a nice big space for it. Okay, I'm going to start with the apothem. I'm going to change colors here so I can keep track of things. I'm going to draw in the apothem. I'm going to use the bottom part of the hexagon instead of turning my iPad. So I'm going to say, okay, here is the apothem. I'm going to call that A. That's what I'm looking for. I'm going to draw on the radius, which I already know is 8. There's my right angle. Then remember, I'm going to find out this angle right here. I'm going to do 360 divided by the number of sides of the triangle, which is 6, divided by 2. And I get that angle is 30 degrees. So now I can find A using SOHCAHTOA, which is the apothem. This is adjacent. This is the hypotenuse, so I'm using cosine. Cosine of 30 degrees is equal to adjacent, which is A, over hypotenuse, which is 8. Put cosine over 1 and cross multiply to solve for A. I get A equals 8 times the cosine of 30. So for A here, I'm going to put 8 cosine of 30. So not the worst answer, but it's not beautiful. Okay, now I'm going to switch colors. I'll do green next. I'm going to get rid of A because I already solved it. I don't need it anymore, but I want that part of the triangle. So, okay. All right, so now I need to find this piece right here. I need to find this piece, the other missing piece on my triangle, because let's say I get that that's 2. Then I know the side length is 4, and there's 6 sides, so that's 24 is the perimeter. See that? Okay, so here's my angle. This is opposite. This is hypotenuse, so I'm using sine. Sine of 30 degrees is equal to opposite, which is x, over hypotenuse, which is 8. Put that over 1, cross multiply, I get x equals 8 sine of 30 degrees. All right, now remember, I need to put perimeter right here. X is not the perimeter, right? X is this piece right here. So how am I going to get the perimeter? Well, first off, I'm going to double it to get this. So times 2 to get my side length. So remember, you can just multiply 8 times 2. So that's 16 sine of 30. Now I need the perimeter. So I say how many sides are there? There's 6. So now I need to multiply this by 6. Yes, you can change that to 96 sine of 30. You can just do 6 times 16. But I'm going to leave it as 6 times 16 sine of 30. All right, now I'm ready to pop this into my calculator. So, well, not yet, because I have to write down my actual plan. So my plan, remember, was to take the area of the circle, which is 64 pi, and then I'm going to subtract the area of the hexagon, which is this whole entire thing. So I'm going to put it in brackets so I don't lose it all. 1/2 times 8 cosine of 30 times 6 times 16 times sine of 30. All right, so we can make tons of mistakes putting this in our calculator. So let's go through it really slowly here just to make sure everyone's okay. So 64 pi, that shouldn't be hard to put in your calculator. Minus parentheses 0.5 parentheses 8 cosine. Before you type anything else, did another parentheses open? Okay, because if it did, if another one opened right here on yours, you're going to have to close that one. 30, if you have to close a parentheses, close it, and then close this parentheses right here. Open a new parentheses, 6, open another parentheses, 16, sine 30. Now the nice part is that you don't have to hit the parentheses 3 times after that. You can just hit enter. The opening parentheses are really important, and so is this closing one. All right. See if you get the right answer. If you don't, send me a message and send me a picture of what your screen looks like. And I can tell you like, oh, you forgot this, like if you're not getting the right answer. The area is 34.8 inches squared. Okay? All right, let's look at this next shape here. What do you see? All right, well, I see a semicircle and a semicircle. So I see 2 semicircles. Now they're exactly the same, so instead of saying I see two semicircles, I'm going to say I see two circles. Or sorry, one circle, because two semicircles makes one circle. The other thing I see is this piece right here. If you look, it's a 3 by 3. That means it's a square, not a rectangle. So I'm going to write down what I see in my plan. So my plan here is I see a square, and I see a circle, and I'm going to add them. Okay, so let's follow through on our plan here. Let's start with the square. So area of a square. Area of a square is side squared, or you can do base times height. I'm going to do side squared. So 3 squared, and I get 9 inches squared. But notice if you do base times height, you'll get the same thing. Now I'm going to find the area of that circle. Pi times radius squared. Okay, so I need the radius of this circle. Now remember, this is a square, so I know the whole side's 3. So the radius is 1.5 inches. So I can put 1.5 right here. All right, remember, I'm going to get my exact answer first, so I need to know what 1.5 squared is. That's 2.25. Don't forget pi, because I didn't put that in my calculator yet. Inches squared. All right, now I'm going to follow through with the plan. Take the square, which is 9, and add the circle, which is 2.25 pi. I'm going to put that in my calculator, just the way it looks, 9 plus 2.25 pi. And you should get the area is 16.1 inches squared. Okay, 2 left. This one here, we need a plan. What do I see? Semicircle. And I see a rectangle. The figure is made up of those two together, so my plan is going to be to add them. Start with the area of the semicircle. So area of the semicircle, is 1/2 of pi r squared. There's not 2 of them, so I'm not going to change it to pi. I'm not going to change it to get rid of the half. There's just 1, so I'm going to keep the 1/2 there. I need my radius, so I need this length right here. Do I know that whole length? It's 8. So that length is 4. So the radius is 4. Once again, I'm going to get an exact answer first. So what is 4 squared? 16. What's half of 16? 8. So this is 8 pi feet squared for that semicircle. All right, now I'm going to find the area of the rectangle. Area of a rectangle is base times height. 8 times 15, which is 80 plus 40, so that's 120 feet squared. I think it froze again. No, it didn't. 120 feet squared. Okay, now I'm going to follow through on the plan. The plan was to add those. So I'm going to do 8 pi plus 120. So 8 pi plus 120, enter. Should get 145.1 feet squared. All right, the very last one here, and then you can get started on the homework. I want to find the area of the shaded region, so I need to know what my plan is. Okay, so I see a whole circle. Then I have to get rid of half of the circle because I have to get rid of this, and then I have to get rid of this triangle. So instead of, I can say, you know what? This half of the circle is not even part of it. So I'm going to say, oh, that's how I can get the shaded region. I'm going to take the semicircle. So my plan is going to be take the semicircle and then get rid of the triangle. That's my plan. And then I won't even have to worry about this part right here. Okay, let's do that. Let's start with the area of the semicircle. So area of semicircle, 1/2 of pi times the radius squared. So what's the radius of that circle? 10. Once again, mental math here. What's 10 squared? What's half of that? 50. Notice I didn't ask you about pi yet, so pi is still there. 50 pi centimeters squared. All right, now let's do the area of the triangle. 1/2 base times height. All right, so now what you have to remember is that the base and the height of a triangle are perpendicular, right? So do I have perpendicular lines anywhere? I do. I know that these two lines are perpendicular because I know that's a 90-degree angle. Why do I know that's a 90-degree angle? Go back to last chapter. See how that's an inscribed angle? That means it's half of this measure. That means it's 90. So now that I know that that's a 90-degree angle, I can see where the base and the height are. Here's my base, here's my height, or vice versa. So I have one of them, that's 16, but I don't have the other. How am I going to find that other piece? Pythagorean theorem. 16 squared plus x squared, because this is going to be my x right here, equals 20 squared, because that's my hypotenuse. 256 plus x squared equals 400. Subtract 256 from both sides. X squared equals 144. Square root, remember you don't have to plus or minus because I'm solving for a length. And I get that that's 12 centimeters. So this is 12 centimeters. All right, so I'm going to do 16 times 12 and take half of that, or 0.5 times 16 times 12, and I get 96 centimeters squared. Now I can follow through on my plan. I said I was going to do the semicircle, which is 50 pi, and I'm going to subtract the triangle, which was 96. So now I can get my final answer. 61.1 centimeters squared. All right, that's it for composite figures. So notice you do have to pay attention. You have to see, am I adding the two pieces together to get the whole thing, or is it where I have to subtract something so that I can get it by itself, okay? All right, go ahead and get started on your homework. Your homework is called 10 Homework 5. When